We're beginning geometry with a brief review of an algebra skill, simplifying radicals, that is critical to your success in geometry. You will have to write radicals in simplified form in probably, I'd estimate 9 out of 10 of the units in geometry this year. So remembering this and being able to do it is important. Our essential question is, how do I simplify radicals? It's really helpful to know the first 20 perfect squares when you simplify radicals, because when you recognize a perfect square, you can then take the square root. All right, so 1 to the second power is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Pause the video for a moment and fill the rest of this in. How'd you do? Most of you are probably good up through 144, 12 squared. And after that is when they start getting iffy. You really need to memorize these first 20 perfect squares. It's going to make your life a lot easier as the year goes on. So writing your answer in simplified radical form is an expectation. Don't ever ask me, do I need to write this in simplified radical form? Because the answer is always yes. It's like your algebra teacher probably told you, don't ever ask me, do I need to use order of operations? The answer is always yes. Okay. If you have the first 20 perfect squares memorized, simplifying radicals is so much easier. So, I personally, when I hit a number I don't know the factor pairs of very quickly and easily, I use prime factorization to help me find simplified radical form. Take a moment and circle the prime numbers on this list. Check your work. You really need to know your prime numbers up through 13. Knowing the next 4 is very helpful, but not quite as important in regular geometry. Honors definitely has to memorize up through 29. So why is that important? When you don't have a simplified radical, you have to find the prime factorization. So, let's see how we do that. First off, check to see if you have a perfect square. It's always kind of sad on a test or a quiz to see someone go through the whole prime factorization process when you are asked for the square root of 100, which is simply 10. If you don't have the perfect square, find the prime factorization of your number. Circle all of the pairs. Square roots, you're looking for pairs of numbers, squares of numbers that can come out of the radical. Multiply each of your pairs, and this comes out of the radical. Multiply anything left over, and this stays in the radical. So let's try a couple. The square root of 81 is 9. The square root of 24, on the other hand, okay, let's take a look using a factor tree. 24 is 4 times 6. 4 is 2 times 2. 2 is prime, so I can stop. 6 is 2 times 3. Both 2 and 3 are prime, so I can stop. I have a pair of 2's. They come out. 2 times 3, each do not have a pair or a partner, so they're going to have to stay under the radical sign. 2 times 3 is 6. Now, this is not how I was taught to find prime factorization. I was taught to use division. and to start off by dividing by prime numbers. So because 24 is even, I'm going to divide by 2, and my answer is 12. 12 is even, so I'll divide by 2, and my answer is 6. 6 is even, so I'll divide by 2, and my answer is 3. I have a pair of 2's, which come outside the radical, and then 2 times 3 have to stay inside. Either method is fine. It's just a matter of how you're taught and what makes the most sense to you. Let's look at 63. 63 is 9 times 7. 7's prime, but 9 is not. 9 is 3 times 3. So there's my pair. The 3 comes outside, the 7 stays in. The way I was taught to do this, I'm going to divide into 63. 63 isn't even, so 2 isn't going to work. But if I add 6 plus 3, I get 9, and 9 can be divided by 3, so that means 63 can be divided by 3. 3 goes into 63 21 times. I know that is 3 times 7. Here's my pair of 3's, and there's the 7. All right, I want you to take a moment to try the next one. Pause your video. All right, check your work, please. Make sure your answer is 5 times the square root of 5. I want you to try the 3 problems on this page on your own. Pause your video. All right, so please check your work. For 27, 3 times the square root of 3. 432 comes out to be 12 times the square root of 3. And this is a great example of why I don't really like factor trees. Look at how these two 2's ended up over on the right-hand side. They're pretty spread out from each other. And then I almost forgot about the leftover 3 down there because it got hidden in everything. I'm not a fan of the factor tree because I lose track of stuff. I really like the division because, to me, it's a lot neater. Even when the 2 numbers are not right next to each other, I still find the division method to be neater, cleaner, and easier to make sure I don't forget anything. Our last answer here becomes 7 times the square root of 30. Please take a minute and write a summary on how to simplify radicals.